Good evening, everybody. My name is Akash, and I'm from SRM AP College. And my topic to present is my project title is loan status prediction using ML machine learning model, and which basically I give a brief introduction what is it, and which involves applying various machine learning techniques to predict the outcome of the loan. And the primary objective is to build a reliable model that can assist financial institution potential risking and any other things. And my data set contains records of uh, 2000 and with 13 features of loan ID, gender, married, dependency, education, self-employment, applicant income, co-applicant income, loan amount, credit, property, and loan status. If he is eligible, then yes. Otherwise, no. So if we go so this is the overall the data description of the data set. And if we further grow we see these libraries like matplotlib and cbond. So basically the matplotlib is like a core library for plotting in python, and its uses are it provide functions to plot charts like line bar, scatter, etc., and custom visualizations. And if we are all aware of this pandas and numpy, so numpy is a very fundamental package in the python, and it is used for numerical calculations, especially when working with arrays, etc. And we are reading this data set as I've already shown before, and it's basically printing df shape means it generally displaying the rows and columns, how many are there. And yeah, in machine learning terms we call as records rows and features. And df.it, we all are aware of it. Like basically it displays first five rows or for first five data. And if we further go, like standardizing columns, basically these standardizing columns means like it ensure consistency and avoids the issues during the data manipulation. And we standardize these column names by making them lowercase and replacing the spaces which are with underscores. And the the main code like df dot columns, it indicates like it access all names of the data frame. And str dot strip, str dot lower, it basically str dot strip basically removes the leading and trailing white spaces. And str dot low is like converts all the column names to lowercase. str dot replace means it replaces the underscore with the it replaces spaces with the underscore to remake column names with the python friendly. Later it's basically prints the columns as we all did. Like if there are spaces, it replaces with the underscore. If there are any uppercase, it replaces with the lower, all these things. So if we observe here, like loan id, gender, these all are in the format of the standard column names. Like if there any space, it replaces with underscore, and if there any uppercase, it replaces with the lower score. So later if we go like feature engineering, like it is the process of creating a new input features from the existing data to improve the model performance. The feature engineering, if you observe the code, like df.income, like it basically doing it is adding two features, applicant income and the co-applicant income. And it also gives like a better sense of financial strength than looking to the separate incomes, the income separately. And if we go down, like it is creating a loan to income ratio, and this ratio basically shows how much the income is being borrowed. And a lower ratio usually means a safer borrower. So a log transformations, this log 1p, we are all aware much. The log transformations help reduce skewness and make the distribution more normal, which many ML models prefer. And if we go down like plot distributions, this subplots to fit. Basically, it depends like it is a 2 grid. It creates a 2 grid using the matplotlib. Like we have already uh, told in the above. Like one library we have at the top of the thing we have discussed like library matplotlib. Like this basically creates a plot, a graph to be precise. Like you use this grid. Why we are doing like this? Like we use this grid to show four like histograms, like histograms it show. So if we clear observe this all the four graphs, the total income distribution to the one graph, like the y-axis contains the count and x-axis contains the total income, and the second graph and the similar the third graph shows like log of total income. It basically having the y-axis count and x-axis log total income. It basically shows the plot of how of your data points in the data set. It is just plotting it, that's it. Like we already combined some features as well, so yeah, related to that, corresponding to that. And that's it, the four plots mainly. And if we go further, like outlier detection and the outlier detection removal, like it outlier usually uh, unusually high or low values that can distort statistical analysis and affect the machine learning models basically. So basically, we are doing like creating a list of numerical features to check for the outliers. For before checking the whether it contains the outliers or not. Later, this is already we done in the before like PLT dot figure. Basically, create a canvas of size 14 is to 14 cross 8 inches for plotting the four subplots. So the program corresponding with by for I call enumerate. Basically, does like it arranges a four boxes plot with the 2 in 2 cross 2 grid. And and SNS box plot basically does like it creates a box plot using showing the median quarters and outliers. Like we can keep any color, not only orange, you can keep any color you want. There's no but like strictly we have to use that or not. There is no, you can use any color corresponding to it. And later these box plots after removing the outliers, these all things like we have idea of what LQ1, Q3, IQ or lower bound, upper bound filter. It corresponds to it. If we have idea, we can like this. We can do this. And later filter data color teal. You can keep any color you want. There is no like we have. There's no strictness like we have to only use this color. There's no like you can use any color you want. So later, these are the corresponding plot graphs according to this code. And if you go further, categorical encoding is one. It is one of the very important. Like before applying this categorical encoding, it's important to understand the distribution of these categorical variables. The steps involving missing values. The main point in the pre-processing is missing values. So our data set is clean and missing values. So we doesn't found any missing values. So that is easier for us as it is already like pre-processed. And if we observe the categorical blocks, like it creates a list of categorical columns to visualize. So these features are non-numeric, like typically encoded before modeling. And the step two, like if it creates a 16 cross 2 inches grid. As we discussed above, these came third time I think. Before two times have come like similar like 4 cross 2 cross 2, 16 cross 8 we have encountered above. And this basically gives a space to neatly arrange all the plots. So later if we found like subplot, these are similar to the above, like it arranges a 3 cross 2 column grid. So that is the SNS plot. The palette is to set to, you can use anything. Like set to indicates like uses a soft color palette for easy viewing. And PLT title indicates like it capitalize. It adds a clear dynamic title for each subplot. And X6 rotation, it rotates the axis left by 30 degrees to avoid overlapping text. And uh, later, if we observe, this is the corresponding output, and the graphs related to the codes. These are the graphs: count plot of gender, count plot of married, the count and gender in the y-axis and x-axis. Same here also. And the third graphs also having like y-axis as count, education as x-axis, count plot of education, and this represent count plot of self-employed, count plot of property area, etc. Similar graphs, like similar graphs with different feature, like count plot of property area, count plot of loan status, count plot of education, count plot of self-employed, like this. Many, if we observe clearly, yeah, that's it. And if we go further, like removing the less effective features using blocks, so like our goal is to check like strongly each numerical feature relates to the target. The target variable ours is loan status, as we already displayed at the starting of our present like at the beginning phase of our presentation. We have already shown the data set where we already considered the target variable as loan status, so we are using the classification. So that is, as it is a categorical values we are having, like as no or anything like 0 1 also comes under categorical values. So later, if we go like, so features to compare, like it also prepares a list numerical features to compare against the target variable loan status. And these features you evaluate for the predictive power, etc. And yep, the if we go further, plot dot figure, it creates a 16 cross 12. I think this came fourth time. This 16 cross 12 grid, it basically gives, and it's very big enough for the 5 subplots. So that's why I can say that length 16 cross 2, etc. And if you consider the enumerate, we have discussed the loops to the selected features with index I, that is it looping. And PLT, the subplot, basically divides the plot area to 3 cross 2, placing each subplot sequentially. And the box plot, basically the loan status of x-axis and y column, like every feature of the y, every feature will be at y-axis. The palette color is cool warm, but basically indicates like uses the red blue color scale for visual contrast. And the call out replace is already we encoded at the starting, like replace it basically if any underscore occurs encounters in our core encounters, so it basically replaces with this space, like white space. So similar to it. And type layout, PLT show, like it basically shows the diagram. So it like this graphs will show like with every column in our data set, it compares the loan status of every graph. If we observe clearly, applicant income versus loan status, co-applicant income versus loan status, loan amount versus loan status, total income versus the loan status, loan to income ratio versus the loan status. The corresponding here with Y as applicant income and x-axis with loan status. So every feature will be at y-axis and corresponding x-axis will have loan status. Thus, every graph they plot, like I plot. So if we go for this correlation analysis is very important in our thing. Like it's very crucial. Like it understands the relationship between features, correlation analysis, and it identifies the most influential features using a machine learning model. Like in our thing, we are using like random forest, decision tree, logistic regression. So it basically identifies the most influential features using a machine learning model. And it, yeah, these are libraries, corresponding libraries, like importing a random forest, sklearn preprocessing in label encoder. This is like label encoder, basically like we converts the categorical values to the numeric. That's the thing. And If we go further, encoding the category, like basically the first line, like df encoded df copy, basically creates a copy of our data set to avoid changing the original one. So that's the thing. And label encoders, it's a normal one. We are aware of it. And the all the select types include equal to object. Basically, it selects the categorical columns. Like categorical columns means you can tell like object types. So for every categorical column, a label encoder is used to convert the text labels to the numeric codes, and which is stored in dictionary form. That's the thing. In case if we want to reverse the encoding later, we want, yeah. Then the PLD dot figure basically gets this time we got this like same amount. So 12 cross 8. It creates a 12 cross 8 grid just to store the subplots. And if go further, core and not CMP, cold warm basically uses a blue red color scale. Like blue indicates like a strong negative correlation, and red indicates the strong positive correlation. That's the thing. And it basically helps to detect relationship of each feature with the loan status. That is our target variable. And we go for the feature importance using like, okay, we are using now random forest. So all the features except the target variable and an identifier like loan ID, except these, all will be targeted, all will be taken as X and Y. We have the class like target variable, and we are using the random classifier. It's a inbuilt one, creates and trains automatically in this inbuilt function. Uh, it is a random model, a random forest model. This model dot fit x comma y. We are aware, and important like it gets the importance score for each feature from the model and sorts them in the descending order. Like if we observe clearly, ascending is equal to false. Ascending is equal to false means it basically sorts them in a descending order, so the most important features come first. That's the thing. And the plot feature importance, it's a horizontal bar chart with 10 cross 6 grid. This is the thing. And X important values, like creates horizontal bar, and palette is called viridity. It's like smooth gradient color for the better visual impact, and helps identify which features are most useful for predictions and which ones should be dropped. That's it tells. And why these correlation analysis is matters means like it helps in spotting the redundant features, and also helps in understanding the relationship between the input features and the target one. And random forest important helps in like focusing your model and on the most relevant features, possible reduce overfitting by removing the weak predictors, etc. So satisfies it is very important. And the corresponding thing of it, and loan ID, gender, correlation, heat map, and the feature importance from the random forest. These all things, and the result and analysis what we have gained, like writing this code based on the data set we got to know from this. And if we go like from sklearn is mostly used in machine learning. So it imports the machine learning models. Basically these are all the five for starting five libraries. Like it basically imports the machine learning models and evaluate metrics based on that. And we also test and split if we needed. And confusion matrix, it's a very random evaluation matrix for evaluation metrics for the classification models. So that's why we gonna use that also to come like how much we are getting accuracy, and the corresponding confusion matrix through confusion matrix only we can like basically tells this accuracy, all the things. And splitting the data, like in the encoded one, we are dropping the loan status and loan ID. And in the Y feature, we basically considering the only the loan status target variable only. and we correspond to that we are doing the 8 is to 2, like uh, the train size is like training test is 80% and the testing size is 20% we are considering. The models I have already told in the beginning of our presentation, like we are using three models: logistic regression, decision tree, and random forest. And accuracies of all of them, like we are taking a maximum iterations of 1,000 for better output. So we are training X trains, dot fit, training the model, predicting the on X test, and calculating the corresponding accuracy. This is a basic one, and we are plotting accuracy comparisons as well. So it creates a bar chart of 8 cross 5 grid size, usually comparing the accuracy scores. So it basically helps him quickly see the model performance best. So palette equal to magma, it indicates like it adds a strong color gradient to look better, to see better. So if, confusion matrix is the best model. So I already the project, so I got for like random forest, I got the highest accuracy. So for the best model, like random forest, so we are gonna predict the Y prediction based on the X test inputs and generate like confusion matrix. Like confusion matrix, what we having like true positive, true negative, false positive, false negative. All these things are considered in confusion matrix. And if we go further, like fixed size 6 4 means indicates like 6 cross 4 grid size basically I do. And the confusion matrix display was it displays the matrix visually, and blue color helps in uh, helps in highlighting high low. Can use any color. I use a blue. That's it. Shows how well the model distinguished between the approved and non-approved one. And if we go further, like feature, like feature importance. So it like giving some good information about our project. It is used, and otherwise it is at up to the confusion matrix enough. But for leapfrogging the feature importance for our random forest, because we got highest accuracy for that only. So that's why. So if we go like it retrieves it retrieves importance from the random forest model, and it visualizes them which feature contributed most to the predictions and useful for explaining the model to the stakeholders means like we consider like stakeholders means you who are seeing this. That's it. And yeah, this is the thing. And the corresponding model accuracy, and the corresponding model accuracy, and the model accuracy comparison, as we already wrote in our previous quotes, or the comparisons of like 12 cross 8 grid size and the confusion matrix random forest, we have already drawn because we got the highest accuracy of that only. And the features importance random forest, yeah, I want to show like the accuracy it is displayed here, the above. Yeah, this is corresponding one. Yeah, this is the random forest we are getting the highest accuracy. Yeah, that's it, and done and dusted. Thank you. Sorry, I forgot to show the blog of mine. The loan status prediction in ML. Like the same, the Google Colab codes only. Like based on that only, we have written this. Like feature engineering, all these graphs are already shown in the Google Classroom. The outliers detection, removal, categorical encoding, the corresponding graphs, removing the less effective features using box plot, and correlation analysis and feature selection. And the result analysis, yeah, this is already shown at last. Like we are getting random foresters accuracy have more 97.55, and the decision tree having 95.65, and the logistic having less when compared to this. So 87.5 we are getting, and that's it. Thank you. Thank you all. Thank you.